your TA will have a more detailed expectation for you. And now, in this tutorial, I'll be covering how to start the code for milestone 1. So basically, here are the different components of milestone 1. We have the streets database library. This is a read-only library that provides you with the information you need to draw a map. And you have the main executable and the tester executable. Your main is called when you start your program. And this is different from the tester. The tester is called when the auto tester tests your code. Both your main and tester executable will call the street map library that's implemented by you. Your street map library should contain enough information to do all of the queries that are done by the tester executable. And this will also serve as a wrapper to the actual streets database library. And all of these will need to be implemented by you. So to start, what you will need first is to read the handout line by line. There's no line in the handout that is not useful. In your code, you will need at least one global variable for the performance tests. I'll go into detail about that. And for the global variable, you might use different containers from the STL to store, depending on the type of the variable and the type of the information you need. So your map will be represented by intersections. Each intersection will have an intersection ID that goes from 0 to number of intersections minus 1. Your intersections are connected by street segments. And your street segments will form streets. Your street segments also have street segment IDs that goes from 0 to number of street segment minus 1. So these IDs might overlap, but they are of different types. In your code, you will have a load map function that's written. And this one is just a skeleton for you to add something into it. And there's the close map. So the load map, it will be called whenever your map is being loaded, and the close map will be called whenever your map is closing down for memory cleanups. So whatever data you allocate in load map, make sure to clean up after yourself in close map. So after you do the ECE297 init milestone 1, first thing is to compile and run ECE297 exercise 1 without doing anything to your code. And you should be seeing something like this. So the compile build failed to build unit tests because there are undefined reference to some functions. And the functions are defined here in m1.h. In here, you will see all of the function headers that you need to implement. And every line of comment here is also useful, so make sure you read through them. So usually the comment here tells you what this function needs to do, and there's the speed requirement. Let's use this as an example here, the find street segments of intersection as an example in this tutorial. So the next thing, to fix all of the undefined reference to functions error, create empty stub implementations of the functions, all of the functions in m1.h. If the functions are returning void, then just create empty function for that. If the function is returning something, return something empty for that. Until you get no more build errors with the ECE297 exercise command. And this is what you should be looking at. So there are no more build errors, but you should be failing all the tests because there's no implementations of any of the functions. So your goal for muscle one is to pass all of the tests listed here. We have 4 functional tests and 4 performance tests, 1 test for load map and one test for val grind. That's the memory check. Find intersection street segments. This is the example that we'll be covering in this tutorial. In the header file, in the comment, it should tell you what this function does. It returns a vector of all of the street segments connected to an intersection, given the intersection ID. And it returns a vector of street segment ID. So in here, our only input is the intersection index number. So we need to use something that is outside the scope of the function by calling the external database API in streets database API.h. This is also a header file that you should be reading from top to the bottom. And for example, if we want to get the information for a single street segment, it's stored in this struct type, street segment info. So for each street segment, it has an OSM ID defined. So the OSM ID is different from the street segment ID. This is the ID that is unique universally. So your OSM ID for a street segment will be guaranteed to be different from the OSM ID of an intersection, for example. The street segments from and to intersections. One street segment connects 2 intersections, so it has a from and to intersection index. A Boolean saying whether this is a one-way street segment. The number of curve points is used for drawings, and yeah, you need to read through that later because this is not relevant to the function we're looking at. The street limit and the street ID that this street segment belongs to. We have some other functions in street database API.h that could be useful for what we're looking for. Get non-intersection street segment given the intersection ID. What this does is it gets the number of street segments connected to the intersection. Get intersection street segment. It takes in the intersection ID and the segment number. So the segment number goes from 0 to whatever's returned from this -1. And then after we get, and then this returns the street segment index. And then you can use the street segment index to get the actual street segment info. So the naming convention is basically get for lookup. The number of street segment. This is the attribute. Number of street segment for this entity intersection. And usually this is often matching with the first argument being given here. So we're given the intersection and we're looking up for the number of street segments connected to it. Say we have this intersection here at St. George and Galbraith. It has an intersection ID of 232. It has 3 street segments connected to it. When we call get num intersection street segment 232, we get 3 because it has 3 street segments. Next, we do 3 iteration of get intersection street segment of 232 and 012. And this returns us the street segment IDs respectively. In the end, we can get the street segment info by using the get street segment info function to get the actual struct. But just be very careful that the intersection index, street segment index are all type defines to integer. So even if you accidentally pass in a intersection index into a street segment index, your compiler will not notice that because the compiler will treat both as integers. So be very careful. If you can, in your variable names, make sure you have the street segment name for street segment index, something related to intersection, to the intersection index types. So let's try implementing the function find street segments of intersection. So you can open up a text editor or anything and try implementing the function here. This function takes in the intersection index and it wants to find all of the street segment IDs connected to the intersection and put that into this return vector. And because we're time constrained, let's just quickly do it, and if not, let's do it together. All right, can anyone give me any ideas on how to start with this? Can anyone give me any ideas? Come on. Yep. We get the number of street segments connected to the intersection using get intersection street segment. And then we use a for loop. And then but for this, we just need the street segment index in the vector that's being returned, right? Yeah. We just get intersection street segment and push back into the vector. So we do get non-intersection street segment to get the number of street segments connected to the intersection. In the for loop, we do the get intersection street segment, intersection ID and I to get the street segment IDs and push that back into the SSIDs vector, then return. Yeah.
Like for all the vector functions, do we know like what time complexity they have, or you just assume that you like the teaching so you made it something?
For the get functions like these ones, they're usually you can assume them to be O1.
So you just like always assume that it's possible that like
yeah.
Like, that
yeah. And after this, when you run the ECE297 exercise tester, you can choose which tester to run by using -- run tester and star intersection star. You can do this, and you'll see that it will only run the testers that are intersections. And after we implement this function, we'll see that the functionality test is passing, but the performance test fails. And this is because functionally this works, but it's not fast enough. In m1.h, in the comments, you should see the descriptions for the speed requirements. If it's a high speed requirements, this function must be very fast. And this function must be faster than how you will be just getting the data from the streets database API. Moderate, this function is speed tested, but usually it can be done with a more naive, straightforward implementation, like just calling streets database API functions. If it's none, this function is not speed tested. And for this function that we just implemented, it requires a high speed requirement. So For our implementation, assume the get functions are all O1s to the street database API. What's the complexity of this function? Of n, and what's n? So typically we say O of k, and the k is the average number of street segments connected to each intersection. Can we further speed up our function? Yeah. We need to pre-compute the data. So in your load map, there is a massive hint in the comment. Load your map related data structures here. Let's think of what data structure can we use for that function for intersection street segments. So we have as input the intersection ID that is an integer and that is ranging from 0 to num intersections minus 1. The output is a collection of street segment IDs, which is a vector of int. Let's keep this in mind and let's go to the STL data structures. We have the vector, the list, the map, the unordered map. The input for vector has to be, the input for vector has to be an integer. Output is a templated type. Input for list is an iterator. Output templated type. Map is map and unordered map both taking some templated keys, and output are all templated values. Which data structures can be accessed with the integer input? Which one or ones of the data structures that we just saw can be accessed with integers? It's just you. Yeah. Vector map and unordered map. And the list can be accessed very inefficiently because you have to go from the, but you can, in theory. What can these data structures store? They're templated, so essentially everything. What is the complexity of accessing elements in the data structure? We have vector, which is a random access array. You can access with O1. The list, O of n, because you need to go from the head and to the next until the actual number. The map is O log n. It's a binary search tree. Unordered map is O1. It's a hash table. And we want something that's less complex than O of n. So the best options will be chosen from vector and unordered map. Because both of them takes O1. For the vector, an access involves obtaining the address for the first element and adding the index onto it, then do a direct memory access. So basically a direct memory access. A load instruction, because a load instruction can do the addition in one instruction. Unordered map needs to first call the hash function to get an index and then do a direct memory access. So this is going to be slower than the vector because the hash function takes time. So when do I need a hash function? When the input is not an index, that the vectors are less efficient than using hash. Because vectors, like arrays, are indexed using a number, and it needs to be a continuous range from 0 to a number of something minus 1. If your input number is continuous from 0 to size minus 1, the vector is always the best choice. If your input is not an index, for example, if we are accessing something by string or by something that's not an integer, or if we are using a really big number that's not really continuous, in that case, a vector with that many elements will be too big and most entries will be empty. So that takes up too much space. So not recommended. Use hash. Like if we're indexing using the OSM IDs. The OSM IDs, because they are unique for all sorts of elements, it will be very, very big. And because it's shared amongst all of the cities, it's going to be even bigger. So use hash in that case. But in this case, we use vector. Because the intersection IDs are continuous from 0 to number of intersection minus 1. And the output is a vector of 3-segment index. So we just do a vector of 3-segment index. We set this as a global variable so that we can set it in the load map and use it in the function. What this global variable does, how this looks like, a vector of vector is essentially a vector of int. And for each vector of int, it has a vector representing the street segments connected to the index, to the intersection index, the intersection. So if you need to access, for example, the intersection 1 street segment IDs, you just return intersection street segments 1. And this will return the entire vector here. Is that okay? So how would you populate the intersection street segments in the load map? We first create empty vector for each intersection. We resize the intersection street segments, which is the larger vector, so that we don't take any overheads while expanding the vectors. And this creates empty vector for each intersection. And then we go through each intersection using a for loop. Inside the for loop, we have whatever we had in the last function implementation. We use a for loop to loop from 0 to number of intersections, 3-segment intersection. And call the get intersections 3-segment intersection I. Then we go into the global variable, intersection street segments. We index it using the intersection ID. So this entire thing is a vector. So we push back the current street segment ID. Is this okay? Is this clear? After this, we will have a filled out intersection street segments that contains the street segments connected to each intersection, and we can use an index to access it. And then the find function is just one line. Intersection street segments, intersection ID. Return. So then the time complexity for this is 01. Then the function is faster and you should be passing both of the intersection tests. Just be careful, there is a performance test for load map 2. It's not a very harsh test, but still make sure you're not abusing that. And yeah, and I'll reserve the rest of this hour for questions on milestone 1. Yeah.
So am I supposed to be ready before the CI meeting, or should I just wait for the CI at the time?
Do you have a group yet?
Yeah,
Yeah,
yeah. So I
you have to start with this.
mean, like before the CI meeting, right?
I'm a TA. I'm not the CI, so you should be asking whatever you need for the CI to the CI. Yeah,
You know, for the team charger that we're supposed to fill out.
also for the CI. Also be prepared for the TA meetings as well.
Isn't the CI meeting this week?
Yeah,
There's quite a bit of like folk style requirements. Yeah, I saw in the rubric that it was like a specific style.
I'll be doing code style tutorials.
It's like.
I think it's next week.
Yeah,
I,
rates the code style by. Right?
yeah, yeah.
You can just look at.
So for practicals, each week your TA is expected to see some progress update. Well, if you started working with this for the first week, then you're ahead of a lot of people. We're expecting a task breakdown at least.
Like we make the text of the task breakdown before going into this.
You can ask your TA about their expectations. Because they will have the detailed expectations. But if you have a task breakdown before going, your TA will be happy. The coding style is tutorial 5. So the coding style is tutorial 5. So that's 2 weeks. Yeah.
Which function would you recommend we start with the milestone? Like, do you have any specific one?
You should be reading through the function requirements and do the task breakdowns accordingly, because you likely need to group related functions to one person.
Okay.
Yeah.
Okay. Are there some functions that are like harder than others, just so you know which ones might like ones that involve more algorithm or data structure we should consider? Like you're talking about hash tables,
Like most functions are like that one.
the hash table,
No, like what I just
the for showed.
the intersections physics.
Okay.
Most ones are like that one, and yeah, you'll see the ones that are more complex. Once you yeah, you need to read.
Okay.
Yeah, and do the task breakdowns first.
Task breakdown just means like who goes through what?
Yeah, do a very scientific task breakdown.
Okay, so
Yeah.
just like writing down like what each function does and like referencing them to each other.
Yeah.
Thank you. Yeah.
You mentioned in the beginning, like we have to show the TA like a week for each week.
Yeah.
Like how is there how do you show this?
Like on your weekly, typically we're looking for a table that with the task breakdown.
Is it like safe somewhere? Like a report?
I'm not sure,
Oh, okay.
but your TA should be mentioning this too
When am I going to see my TA?
in your practice.
And I'm practice. So I'm also gonna show my work. What happened to the second tutorial?
I'll do the same presentation if there are people coming.
So for I think you mentioned like for for vector you use it because you need an index, right? So how about the map versus vector?
A map versus vector?
Yeah.
A vector is a 1D array. A map is a binary search tree. So the structure itself is. So in the last tutorial, I went over the containers. So So for the map, use it when you need the keys to be ordered
Oh,
and you're searching for something binary. Multi-map, use it when you need the map, but you need a duplicate keys. On word map, use it when the order doesn't matter. So because our map is not ordered, you cannot order it in any ways. So if the order doesn't matter, our map is the fastest. And the set is just a binary tree without values. Just
things like this is like very inefficient. So is there any scenario that you want to?
for this, it's too inefficient that there's not much usage.
Oh, so it can be replaced by either vector.
Yeah.
Okay.
Usually you can just pick between vector and order map. That should cover
Order,
order map. Yeah,
not even that.
not even map. That usually covers all of your use cases.
Okay.
Because in most of the times you will need something O1.
Also, here, sorry, why is it's going to record this?
This,
Yeah, where's
the first line.
Yeah, the first one.
The first line just calls the load map in the street database API.
That's like the
That's like opening up the API.
no.
Yes, we can. Yes, we can.
Like, we return this one. This is like, why is it Boolean?
So load successful. So if you get a load successful, it means the street database API is loaded correctly. If you get a false, then it should be terminated anyways.
This is something wrong with the construction.
Yeah.
Okay. Thanks so much.
Yeah.
Well, why is there like I have this right, but there's no space. Last week's recording.
You don't have the opening bracket. So it's only recognizing one line.
What was that? That's not good. Oh, okay.